We're now in a section 1.3 of your book, which starts talking about mass, weight, and even a little bit about volume. The first thing we need to consider before even defining these things is mass does not equal weight. We treat mass and weight as if they are the same, but they are not. If you are talking to a scientist, mass is a measure of inertia. Okay. And what the heck is inertia? We'll get back to that in a minute. But your book starts by talking about kicking cans, okay? Okay, you kick an empty can. Can't spell. And you kick a full can, a can full of rocks. What's going to happen if you kick the empty can? It's just going to go flying off, right? It's going to accelerate very quickly. It's going to start moving very quickly. If you kick a can full of rocks, it is going to start moving or accelerating much more slowly. And if I asked you why, you would tell me that the can weighs more. But it's not really that it weighs more, it has more mass. Can with rocks is more massive. Okay, and something that is more massive has more inertia. Where inertia is defined as resistance to change. Okay, in this case, the resistance to change was change in movement. So we can say that mass is proportional to inertia. That funny fish-looking like thing I just did, that is pronounced alpha. And it means is proportional to. So we're going to be using that quite a bit. So what is mass? It's the amount of matter in an object. Oops, sorry about that. What the heck is weight? Weight is gravity's pull on an object, which we'll talk about more later. Percent 6. Mass and volume, don't confuse the two. Okay, so as long as we're here, let's talk about mass and volume. They're not the same. Volume is the amount of space occupied by an object. over here, the units of volume. You can have a variety of different units. It can be milliliters, it can be cubic centimeters, it could be liters, meters cubed, could be cubic feet, except we're going to be using the metric system. And volume isn't necessarily proportional to mass. If you want to think about that, think about a bag of feathers versus a, let me see, bag of feathers versus a bag of lead. Okay, if you have 1 kilogram of feathers, that's going to be a very large bag. 1 kilogram is 2.2 pounds. If you have 1 kilogram of lead, it's going to be a very small bag because lead is much, much denser than feathers. So where the volume of the feathers is always proportional to the mass of the feathers, and the volume of the lead is proportional to the mass of the lead, the volume of the feathers and lead are not proportional to one another.